welcome back to my YouTube channel. Now in this video, I'm going to continue with where we stop. Now previously, we'll talk about chapter 5, SPM physics. We talk about the structure of an atom. We have nucleus, where in my previous video, you may want to refer. We have this symbol, we have A and we have Z of an unknown element, of any element X, okay, where the number of nucleon is A and number of proton is Z, okay. We have talked about this symbol during my previous video in Form 5 Physics, Chapter 5. So here today I will talk about radioisotope. Okay, now it's actually a continuation from what you have learned from chemistry, Form 5, SPM. You learn about this term also. So therefore I'm going to guide you through the physics aspect. What are the things that we will look for in radioisotope in physics? So first, I'm going to bring back the same structure of an atom, which I have drawn in my previous video. So an atom of neutral atom, we have a nucleus, but instead of radioisotope, for radioisotope they have actually a definition in SPM. It's actually the atoms of the same element have the same proton number but different nucleon number. Okay, so meaning radioisotope in objectiveness, when it comes up, they all have the same proton but different neutron number. Okay, so say for example, I have here same element of hydrogen. This is the nucleus of a hydrogen. Okay, nucleus of a hydrogen, we have electron, have actually one electron. Okay, in the outer orbit. I didn't actually draw and in the outer orbit. Okay, so quite limited space here. So we expect to have one electron and they're going to have one proton. Okay, so it's possible. Let's not talk about just hydrogen or what element. We talk about an X element. Okay, an X element of an unknown element. But of course, if you have only one proton, then you know actually this is hydrogen. But we didn't name it yet because in the atom they don't have a hydrogen atom. It's just that we scientists acknowledge that when the nucleus will have one proton, that atom we name it as hydrogen. And you have two protons, that we name it as helium. Okay, so for this case, for a radioisotope, let's say for example deuterium is actually a hydrogen, but instead they will have different number of neutron. Previously I think I used green, so neutron. Okay, have one neutron. And then triton, what happens if you have same amount of proton but different neutron? Okay, alright. No, I think I make a mistake here. So they are going to have 1, 2, 3. So maybe you have 1, you have 2, you have 3. Okay, so we are talking about the neutral atom. So number 1 proton, 1 electron. I think we have gone through that part in my previous video, how to calculate the number of proton, neutron and electron by the model. And they are all the same element. Okay, it's possible to get this. They are all considered a radioisotope. Okay, so the definition I've learned from chemistry, SPM chemistry. This is the definition. I think I will do it in a physics way. It is still the same. We talk about isotope. Okay, iso, same. Okay, isotopes. What does it mean by isotopes? Isotope is actually element or atom of the same element, same element, same element. They are going to have the same proton number. In this case, they have 1, 1, 1, same proton number, but I'm going to highlight it using a but. You have different neutron number, or you have different nucleon number. Okay, this is the nucleon number A. You seriously need to go back to my previous video. You need to refer to my previous video if you have no idea what's happening. Okay, this is actually a combination of the proton and neutron number. Okay, so this is isotope. So how about radioisotope? Okay, so when we talk about radioisotope, so radioisotope meaning some element they're going to have the same proton number but different neutron number. It's just that now this this element would have it tends to decay. Okay, so this is actually isotope with unstable. I don't mind if you want to copy this and make your own notes. Normally I would advise students to watch my video and then make your own notes at home, and then you may want to add in more notes eventually once you have read through your reference text. With unstable nuclei and tends to decay. Okay, so well, it seems like something new. Tends to decay. We'll talk about decay or radioisotope decay slightly later. Just that let's make do with this. Isotope is this same element, different element. Different nucleon number. But then this isotope tends to decay, meaning tends to break, or they have this word called unstable nuclei. Okay, what does it mean by unstable nuclei? Okay, it means okay, maybe an exclamation mark. It means whenever a nucleus they are considered too big. Okay, too. I want the exclamation too big. Okay. What does it mean by too big? Okay, let's refer back to this diagram or this diagram, either one of it. Now, as when your nucleus increases, what happens? You need to study something here is that what binds them together, what glue them together, elementum. Okay, what makes them to stick together and comes together until to form a nucleus. Okay, that kind of force is considered some kind of force, nucleus force. And scientists eventually found a way to harness the force that bind them together. And they find that this amount of force is so huge, and that eventually able to make a nuclear plant so that you're able to generate electricity. So this is some good use of nuclear energy, some clean energy, some scientists claim. Okay, so this is the energy they want to harness between proton and neutron, what binds together. Now when it comes to unstable nuclei, nucleus are considered too big. There's actually a clear-cut SPM, you get to learn it, as when your proton number, the Z, when your proton number is more than 83. Okay, Now, I'll give you some time to go look for your periodic table, or you may pause my video to go look for a periodic table, and then you'll be able to find out that 83, more than 83, meaning that would be polonium. Okay, 83 is actually, from your periodic table you have, is actually bismuth, Bi. Okay, or when the nuclear number it's more than 209. These are some facts that you should know. Bismuth is very near to 209. Okay, so this is actually bismuth element. Right. So recently, I think scientists have just found out, the completion of this periodic table. They found out the element of 113, proton number 113, 115, 117, and 118. I mean, the completion of the periodic table. Okay. Previously, they have found 114. 114, I think it's actually called flavonorin, Fl. And previously, they have found also 116. It's actually livermorium, Lv. Okay, livermorium. Okay, so in recent few days, okay, I just found that scientists have just found out this element. Okay, today is 2016. Okay, they just found this. Well, of course, this is not stable because the proton number is more than 83. Okay, belonging to the actinide screw. But it's for your information. Okay, we've just found this. So when the nucleus proton number is 83 or 209 nucleus number or more than bismuth, is considered unstable, and they tends to decay. They tend to break into half, so that it will become more stable. When it breaks into half, it becomes smaller, then it becomes other things. Okay. So radioisotope give rise to radioactivity or radioactive decay. Therefore, you get this radioactive decay, this process where the element or the nucleus breaks into half, not necessarily to be half, but breaks into a more stable nuclei. Okay, you have radioactive decay. Okay, radio decay. What happened is, I mean, you will get the definition straight from your book or reference. Okay, what does it mean by that? It's put into a layman term, a short, simple term is disintegration or a spontaneous disintegration is a scientific word lah. So disintegration meaning tends to disintegrate, separate. Okay, disintegrate, break into half. Okay, disintegration. Disintegration of what? Disintegration of, say this is unstable nuclei, disintegration of unstable nucleus into a more stable, into a more stable nucleus. This is basically the definition. But what happened when it breaks into half? Scientists found that whenever they disintegrate, what happened to the energy that previously bind them together? Because, okay, say for example, this proton and this neutron initially is being bind to each other by a force, a strong force. But when it starts to disintegrate, I mean, they break into half this way, what happened to the energy? Because you cannot destroy the energy here, right? So what happened when they disintegrate? So this form of energy will be released. Okay, in the more stable nuclei, And then with the emission, you have emission, okay? With emission of energetic particles. Okay, where does it come from? This energy particles is actually from result of the strong force between proton and neutron. They break to half, and this is what will happen. So now, what are those energetic particles? This is what you will learn. Okay, first thing you will learn from decay is called energetic particle. First thing would be called, or the radiation particles, or the energetic particles. Let's use the word energetic particle. There are only three types. Okay, first type would be called the alpha symbol, alpha. What is actually alpha? It's actually 4,2 helium. Okay, they are going to have plus 2 electron, meaning it's a proton plus electron. It has got a very huge mass of 4. Because of this so large mass, what happened? It is traveling at really slow speed of sound, c. Okay, this is actually the speed of sound, speed of light. Sorry, the background noise is actually from the rain. It's raining here at the time of the recording of this video. So what happened? Put in a graphical form. So they are going to have plus 2 proton inside the nucleus, and then we are going to have proton, and then neutron would be the blue one. In this case, is sharp. Large mass 4 neutron number is 4, mass match, and you have very low speed. Okay, that's the first energetic particle, followed by the second energetic particle they call beta. Alpha, second one is called beta. Beta is actually 0 minus 1. It's actually electron. So this is not proton. Proton is plus. This minus 1 is electron. So it's actually a radiation. Okay, it's an radiation. It's an electron moving relatively fast, an electron. Okay, so the charge, in terms of charge, they're going to have I have gone through it with you actually in the previous video. It's negative 1 e times the charge of an electron, negative 1. In terms of mass, I think I told you already in my previous video. I give you a data sheet. It is very small, very small. You may want to refer to my previous video over the number, or you may want to record from your scientific calculator. Okay, and then the speed wise is quite fast. Consider it is not at the speed of light, but slightly less than that, 0.9 c speed of light. Okay, alpha, beta, and the third one they call it gamma ray. Gamma, okay, it's different than from alpha. Alpha to the left, gamma is downwards. It's a high frequency ray. The high frequency is actually a frequency, very high frequency, electromagnetic wave, EM wave. It's a wave. Okay, so that's nothing. It's not positive or not negative, no, nothing. Okay, high frequency. no charge, no charge, no charge, nothing, just pass through it like radio wave. It's just that the frequency range is different. Okay, you have learned through it in Form 5, Chapter 1. You want to go through it. What does mean electromagnetic? Is wave, it's a form of wave. Okay, and no mass. They have no mass, and it's traveling at the speed of light, because it's electromagnetic wave. See? So this three energetic particle is a result from the disintegration of radioisotopes. Then what else? This is the three energetic particle as a result of disintegration of an element. Say for example, where does it, can we give an example? Yes, for example, say you have a huge, very huge element. Say I have thorium, TH. Say I have thorium, TH. Okay, you may look from your periodic table. You should have your periodic table by now. Okay, say thorium is actually from the actinides group down there, because the proton number is 90. You look for 90. Where's 90? 90. Okay, 90 is proton number, and the nucleon number 230. But of course, more accurate one is 232 point something. But for simplicity, we use 220. For SPM physics is okay. Okay, sometimes they use 232 actually to be specific. Okay, but for this case, I'm going to use 220. I'm not going to use 232. Okay, for practice exercise, let's use 220 for simplicity. What happens when it emits, disintegrate, kind of half? What happened? Says it gets Ra. Okay, and you look from your radium. Okay, you look from a periodic table. It's 88, and 226 nucleon number. Okay, so this is what happened when it disintegrates. So you get radium, but at the same time you should get one energetic particle. Normally they will ask you for this, what would be the energetic particle? So all you need to do is like an equation, mathematical equation, left and right, they are going to be the same. Left are going to be the same with the right. What is the same again? The proton number and neutron number are going to be the same. So in order to match 90, this is 88, to get 90, you have 2. So you need to plus 2, right? 88 minus 2, you get 90. 226, you need to plus 4, then you will get 230. So we have 4, 2, 2 proton, 4 neutron. Straight away you know it's actually helium. So this particle, they call it as alpha. So therefore, they are going to have alpha particle. Okay, in your reference text, okay, or in your exercise, you should try this many times. I mean, maybe 4, 5, or perhaps you can afford to buy 2 exercise book. You get 10 to 12 questions. They will ask you about alpha, beta, and gamma. Also the characteristic. Okay, for alpha, because of the huge mass, okay, it has very low. Okay, to put it this way, you have low because of large mass. Okay, so in order for it to penetrate a piece of paper, there's no way to do it because it's so large mass, you can't penetrate it. Okay, and you can actually stop it by a very thin piece of paper. Let me show it here. Comparison, put it into a chart. Okay, So alpha characteristic, it has very weak penetration. As compared to gamma ray. Let's say for radio FM, it passed through walls and pass through walls, etc. So you're able to pass through things easily. So therefore, gamma ray, it has very strong penetration rate. Okay, so it helps you to know it. Okay, gamma is a frequency. You can pass through walls, right? From house to house, you receive radio FM. It's like a frequency. So you have very strong penetration. Whereas alpha particle would have a very low penetration or very weak penetration. Then for beta, it's always moderate. Okay. In order to stop it, you need to have a piece of aluminum. Okay, because it's metallic, you're able to stop it. So what you do in order to stop an alpha, because of weak penetration, you can stop by thin paper. Thin piece of paper, you stop it. Whereas for beta is electron, so you use thin aluminum. You have aluminum, or you have very thin sheets of aluminum. Thin sheet of aluminum. Now, in order to stop this gamma ray, what you do, like normally you go for X-ray, what you do, you need to wear a very thick or a few centimeters of pumlum, isn't it? A lead. Stop by lead. Lead is actually pumlum. Lead, okay? In scientific, is actually pumlum, or a very thick concrete, or concrete. Okay. So you may go through your reference textbook, okay? How things, the comparison, I think I'm go through it with you. Then you have very weak penetration, but it has got very strong ionizing power. Ionization power. Okay. Gamma ray frequency, it doesn't ionize anything, so this is the weak one. And beta, we have moderate ionization. Moderate, okay? Moderate, I spelled it wrongly. Why? One way to help you to nail it through it. Why it has very strong ionization? Because what happened of the large mass, it has very high momentum. Even though it's traveling at a very slow speed, but it passes through something, it will tend to ionize the air. Right? When a lorry passes through something, anything that blocks its way will be knocked off. So this alpha will easily knock off electron from the air, and therefore it tends to ionize the air. So easily alpha would ionize the air. That's why you have very strong ionization because of the huge mass. Of course, because of the ionization and things like that, it can be deflected easily by electric field. We have learned from chapter 3. And as well as with magnetic field. So electric field and magnetic field will tend to give any effect to it. So in an example, if in the event I have some radioisotope or unstable nuclei placed inside a very thick piece of pumlum container, okay, Say for example, I have an element, a small piece of element, unstable element, tends to decay. You can't see it, you can't see those rays, this is side view though. And then I apply two potential. So you have gone through this, you have seen the setup, right? Previously you have a candle, and then the side they will have two pieces of plastic or conducting element. Then you see the flame tends to be deflected. I think you need to go through my video, then you have seen that picture. Okay, so in the event if I were to apply positive this side electricity, negative this side, now what happened based on the characteristic you have gone through? So first, gamma ray. Do you think gamma ray will be deflected by positive negative? No, gamma ray, that's no charge, no mass. So what happened? Gamma ray would have just travel in a straight line. Gamma ray. Okay. Instead, what happened to beta? Beta is electron, one electron. So electron, what happened? Electron will be deflected. Negative will go to positive. Okay. So the deflection would be, let's say, go up, then very fast it will be deflected to here. This is my beta. Easily, when it comes out, deflected to the positive. You don't confuse negative not going to negative. Negative should go to positive, because different charges attract. Okay. Then go to alpha. Alpha, what happened? Alpha is actually positive, so positive will go to negative. But alpha tends to be deflected, but the angle of deflection will be less than beta because the mass is huge for alpha. So therefore, it tends to go straight, but eventually it's, yeah, this is exaggeration, but yeah, this is how what happened. The angle of deflection when you sketch it normally comes out in essay question or structure question. What happened? Be sure your alpha, the angle of deflection is less than beta, because the huge mass is slightly harder to deflect it, but it will be deflected. Okay, so this is the trick. Gamma goes straight line, beta deflect more, alpha deflect but deflect less. Okay, but make sure it's to the negative side. Alpha is for 2 positive. So this is what you have seen, and you should practice this. Okay, drawing. They will normally come in structure in SPM. The same go with magnetic field. Okay, chapter 3 from 5 we learn about magnetic field. Say for example we have a magnetic field across. I hope you know what does it mean by cross. A cross meaning magnetic field going into the plane. Let's say the magnetic field is going into this screen, going into this screen. Okay, so this is actually magnetic field into the screen, into it. So what happened? Again, gamma ray is just a frequency, it will just pass through it. This is gamma ray. Then by using the Fleming left hand, beta, what happened? Beta will be deflected, but it will be deflected, yeah, easily. Beta will be here. Okay, why? Magnetic field, father, mother, children. Okay, father, mother, children. Current going to the left, because this is electron to the right, so current to the left. Current is pointing to the left, magnetic field into the plane, so therefore there's a force pushing it downwards. Okay, and therefore alpha, higher mass, big mass, not easily deflected, but it will be deflected, but this is a positive charge. So father, mother, children. Father, magnetic field into it. Current is to the right. So yes, traveling to the right, so therefore it will go straight and eventually, yeah. Okay, so this is alpha for 2. This is a positive charge, just like how the current would flow. Okay, so here you have more deflection, less deflection, gamma, no deflection. Okay, So I think this is basically about it. If you want to read more on ionization, one way to help you memorize or understand ionization is to have large mass. So large mass is traveling a certain speed or high speed. What happens? It tends to knock off the electron from the air, not the proton, but the electron. Knock off the electron from the air, so therefore it ionizes the air. So therefore it has a strong ionization factor. Okay, then that's basically all about it. You may want to go through your reference text for more definition or exercise. You should try at least 15 to 20 questions. How to detect alpha, beta, and gamma, and what are the how to find out the energetic particle. They are normally come out to a few process and you find out what is alpha, how many beta, how many gamma. So if you're first time watching my channel, kindly subscribe to my channel and appreciate the thumbs up. Coming up next, that will be Radioactive Decay. We'll talk about radioactive decay. Then stay tuned to my next video.